Alright everyone, welcome back. I have actually missed a few chapters from module 2 and we will be covering that now. So this is chapter 5.11 from module 2. So this part was missed and it's pretty simple and easy to understand. It's all about map reducing. So we have already studied about this in other chapters, but we didn't actually cover this in detail, but now we'll be covering that in detail. So this complete entire chapter, the 5.11 chapter, is based on only 3 diagrams. So you just have to know about these 3 diagrams. So first they will be talking about map reducing. What type of it is? Like software framework in which you analyze huge amount of data by splitting them into different groups and working on it parallelly. So whatever it is, it's like instead of suppose like you want to eat a very large pizza, but you cannot eat it by yourself. But your goal is to somehow finish it. In a sense, it has to be eaten. It's not necessary that it has to be eaten only by one person. So what you do, you call your friends. So now whole one pizza, if you want to eat yourself, you might have to keep it for many days, keep it in microwave or somehow keep it fresh and then eat by yourself. It will take 10 days, very long. So what if you call your 10 friends and you might finish it within 1 hour itself. So it's just like that. Okay, so it has two phases, two things, master and slave architecture. So master is nothing but our job tracker, slave or the worker is nothing but our task tracker. So what job tracker does, it schedules the task, monitor all the tasks, re-execute. So schedule in sense, whatever it receives, so it will schedule like this should be done by this task tracker. So for which task tracker should do which job. Okay, so map reducing and all is not done by task tracker. It is done by slave workers itself, but it will be governed by job tracker. It's like project team, yeah, project manager is there. Does he do all the things? No, he just distributes and divides the work among the team members, and the work is actually done by the team members like that. So schedules the task which task tracker should do. Monitor, it will be keep on monitoring the task tracker whether it is doing or not. Whether it will be checking whether it's working properly or not, because the task tracker's job is to keep on sending heartbeats. We have studied, right? In further model it will be there, so it has to keep on sending heartbeats. If it does not send, then it means the task trackers have somewhat failed or died, so it will be re-executing the failed task. See, that's what monitoring. Keep an eye on it. If something is wrong or fails, re-execute the failed task. Provide the status. So like it's completed or can move to other task, or it is dead or all like that. Where on task tracker, what it does, it executes the task. So whatever the task was scheduled to task tracker, it will be executing it. How? By dividing the input into map, that is the map by mapping, that is not generating key value pairs, and then reducing. Okay, I'll tell very simple mapping and reducing. It's very simple. With an example, we'll do it. Okay, spawn JVM. So it will be spawning the Java virtual machine for the execution. We saw in chapter 4 at the ending, right? Before Pig Latin, I think it was in Hive, in which we saw the Java virtual machine. Sorry, it was in Pig if I'm not wrong, where Java virtual machine is given for each one mapping task and one execute interpreter type of thing. You can see the previous videos to understand that. But this is from model 2. That was covered in model 4. Okay, so be careful with that. Sends heartbeat. So whatever it is executing, it keeps on sending a signal that I'm still alive and working. So if it doesn't send heartbeat for 10 minutes, then it's assumed that the task tracker is dead. Maybe some issue, the worker died, and then we'll put a new worker. We'll just replace him. Then report status. So it will keep on reporting the status about the execution, whether it is successful, that will move on to another, or does it meet any other requirements and all like that. Moving on to that, this is the how client sends the job. Like we are the client, like whatever we want, we'll be asking from the system, that is Hadoop, right? So in that it will automatically send to job tracker. The input will be received as job. So that job is distributed among these people and done like that. After this, we have this MapReduce workflow. They say that MapReduce, it's very fast. It executes very fast, analyzes the data very fast. And but how does it execute so fast? We'll check into this. Why why executes fast is because it is explained in this diagram. We heard that, right? We saw that what it does, it splits the data and make multiple workers work together on the same data parallelly. So basically here, so this is computing task. This is job tracker. What it did, it sends the job tracker, so sends the input or the job to the task tracker. Okay, so here then map task and reduce task. So they are nothing but task tracker itself. Okay, so I forgot to mention task tracker. So this is task tracker 1, 2, and that is task tracker 3. So in map task, what's happening in map task? Okay, before we move to the map task, I'll just tell you. Let me write an example. Exam helper helps with exam. Okay, so basically this is the example what is happening. So what happens, this is the given input, assume this is the given input, and now what's happening, it will count. So it will, what it will do, it will write exam comma 1, helper comma 1, helps comma 1, with comma 1, exam comma 1. That is mapping, that is key value pair. So instead of one whole word, it will divide it and give a particular place. Then it will see that exam and exam has repeated 2 times. So what it will do, it will combine and just remove this exam and put comma 2. See, exam comma 2. So the key value is 2 now, like that. So it will make key value pair. So actually key value pair was generated, right? This is not there, this is exam. So this is mapping. Reducing may, what happens, these two are similar, so it will reduce and become this exam comma 2, this will go. See, reducing won't happen in map task. That is nothing but mapping, dividing the input, splitting the input into key value pair is happening in map task. In the reduce phase, it will aggregate the data. See, if duplicates are there, it will merge. Before reducing, the shuffling and sort will happen. I'll explain that thoroughly when we come to this part. 1, 2, 3, 4, like that. We understood, right? So now what's happening? Job was given to the map task. So now what is happening? See, this connection is for showing that job tracker keeps an eye on map and reduce. Okay, this is not reduce. So the workflow is the pink line which you see. That is the actual workflow. From here, the workflow starts. It goes here, then it goes to final output. It doesn't directly connect from here. He is not doing anything, giving anything to this. He's just monitoring it. Okay, map task. So the task was given here. Task tracker 1, task tracker 2. So he saw that the input cannot be done by only one task tracker or only one slave. So we need more than one worker. So that's why what it did, it's divided the data segment, same data segment divided into 2 parts, so such that it can be worked parallelly. So the first 50% is here, the remaining 50% is here. Both the workers are working on it and they got the output for first half, the output for second half. The both were given to this. So now what is the output? Nothing but key value pairs that was given to this. Here while going here, as soon as come here, shuffling and all happens, so that it's easy to shuffling and sort, like arranging it, shuffling or reordering, like that, and then the final output is generated. Okay, it's very simple. So you saw, right, big data, instead of using only one task tracker, it used multiple task trackers. Then we have the architecture of map, what is that, map reduced programming. Whatever the client sends, the job tracker receives as input, telling that it is jobs, assigning, see, scheduling to all the task tracker, monitoring them. The task tracker splits the data into key value phase, that is mapping, and then the duplicate values are removed, that is reduce phase. Multiple, if the data is very big, so it divides into multiple segments, and each task tracker work on that particular segment and generates the output. This is the architecture. So here actual data word count example is here. So here the same way I said, exam helper helps with exam. So it's first what it does, it will write here. So if I have to say same example I'll take. So what it will do, exam 1, helper 1 helps 1 with 1, exam 1. Shuffle is sort, what will happen, it will shuffle. So it will be like exam 2 helper 1 helps 1 with 1. So see, actually I went to shuffle like in alphabetical order, but anyways it's the same, only this has gone. So then in reducing, so I have to write like this over here, sorry, exam 1. Okay, it will be like this. In reducing, this both will combine and become exam 2. So that is nothing but the word count example that's there in the textbook with a proper neat diagram. Once you see the notes which I have prepared, then you don't have to worry anything about that. This is complete 5.11 chapter. I hope you understood the explanation. We'll see in the next video where we'll be covering the yet another resource negotiator. It's very simple topic. We'll look into that in the next video.